let's understand like right now we are discussing Bluetooth, right? So most of communication protocol work on radio frequency, right? R we call it in short RF, right? So RF communication is kind of transmission of the data wirelessly using electromagnetic waves, right? So either it in GSM and Wi-Fi or LTE or Bluetooth or NFC or what we call it RFID, right? All this communication happen through the radio waves, right? And the signals get transmitted over through the air, right? But there is a standard mechanism, there is a standard transmitter which transmit the data, and there is standard receiver which receive the data, right? And then between this receiver and transmitter, right, there are different kinds of carrier or extender to boost the communication. So everything wireless around you use like mobile phone, Wi-Fi, Bluetooth, TV remote, radio, GPS, satellite communication. All this, right? The RF is the foundation of our wireless, all kind of wireless technologies, right? And how wireless transmission work, especially. So there is two sides. One is the transmitter, second is the receiver. The transmitter is like that. It collect the data, right? Either it could be in a text form or in some kind of through the sensors where you write. So it collect the data, modulate the data. But modulation, that means mixing the data with a strong wireless signal, right? Then after that, through the antenna, it transmit in form of electromagnetic waves through the air with different kinds of speed, right? So this is the part of the transmitter. And when we talk about the receiver, so receiver first collect the data from the air, right? And whatever it is coming over that specific frequency and different format. So first of all, it will collect the data. Then same as that transmitter do the modulation, receiver also do the demodulation. That means extract the data from the carrier wave and remove it, and extract the original data from that carrier wave, right? And then there is also antenna to receive that electromagnetic waves, right? So this is how the two things what is important, that the transmitter transmit the data and receiver receive the data, but between that there is encoding and decoding part of data is compulsory. So carrier wave is like constant frequency wave like 2.4 gigahertz, right? As you can see that in case of Wi-Fi we have two different Wi-Fi's, 2.4 gigahertz and one is 5G, right? Because this 2.4 gigahertz, right, is a frequency at the carrier wave which help data to transmit from one location to another location, right? And modulation is like way of adding data into carrier waves, yeah. And modulation is the process of encoding data onto carrier wave. The carrier wave itself carry no information. It is just a kind of a postman, right, which transmit the data from one location to another location, right? And if you want to understand more practically, so modulation is like changing the carrier waves to represent the data 0 1s in digital format. That means, right, there it is a signal, right? 2.4 gigahertz is a frequency, right? That means if we can modulate it to represent the different kinds of number into the binary language, right, 0 and 1s, right? So you can assume that we are modifying the carrier waves to represent our message, right? Yeah, this is a little bit more deep about the modulation type, right? Amplitude modulation, frequency modulation, phase modulation, and this Gaussian FSK. I think you have heard about only in engineering, right? In network electronics. These are a little bit deep. Not we don't need to learn in that much deep. But if you are curious about how communication is working, you can read into the deep, right? What we care about, like some basic information. This is the frequency that are different kinds of electromagnetic waves use, right? Our radio waves use a different frequency, microwave use different, infrared, detective remotes and light, visible light use different kinds of other frequency. So this is the spectrum that is used by different kinds of electromagnetic waves, right? And this is the frequency range in numbers, right? Let's say 433 megahertz. So it is used by RC remote, chip sensor and LoRaWAN and ZigBee also, right? So it's a range of 433 megahertz, 1 to 2 kilometers, right? It is used for the long range communication, right? You have seen this thing in LoRa, right? And 868 hertz, like long range. So it is used in a LoRa device, but in Europe, right? And it has a little bit more range because it is almost double of frequency of 433, right? Then 915 megahertz, it is also long range. It is used by LoRa in USA, and 2.5 gigahertz, right? It's a medium range, right? So it is this medium range used by Wi-Fi, Bluetooth or ZigBee, right? And it is a kind of most crowded band used in many countries. 5 gigahertz is a little bit short range, right? 30 meter for Wi-Fi 5 gigahertz, but it has a faster speed, like more faster than 2.4 gigahertz, less interface and less range, right? 60 gigahertz very short, 1 to 5 meter, right? It is used for the Wi-Fi and other patterns of the Wi-Fi with high speed and very short range. Then sub giga 1 gigahertz very long range. It is used for the cellular network like GSM and these things. And why 2.4 gigahertz popular in IoT? Right, because all the common communication protocol like Wi-Fi, Bluetooth, BLE, ZigBee, almost all this use 2.4 gigahertz, right? But and it is the most common reason for it. It is unlicensed. That means no one has to buy a license to use this 2.4 gigahertz wave. That's why it can be used by any industrial product, scientific and medical research, right? And yeah, because most of devices and industries are using 2.4 gigahertz, so that's why the network got increased slightly. So for 2.4 gigahertz, like congestion problem, because it is facing congestion problem because now they in a single place there is like lots of devices communicating over the same frequency, right? So that's why later on 5 gigahertz introduced, right? So that congestion or the network traffic get reduced and we can get much higher speed. This is the about signal strength, right? What kind of signal has different strength, right? And we measure that strength into, we call this also RSI value, or measure into dBm. So minus 30 dBm is like excellent, minus 60 dBm is good, right? And this is the number as much as increasing in the into the minus, that is showing that the signal strength is poor for that. And what is frequency hopping in spread spectrum? So Bluetooth uses the technique called frequency hopping. Instead of staying on one frequency, it rapidly hops between 79 different frequencies, right? 1600 times per second. That is the speed of Bluetooth, right? Because it can in a range of frequency, it can switch with one. If one range is busy, then it continuously switch to another range, so that it can transfer data in minimal time, right? So this makes the Bluetooth resistance to interface. Even one frequency is jammed or busy, then Bluetooth just jump into another. Then yeah, antenna is the main important role to collect any kind of electromagnetic signal from the external environment, and antenna is specially designed for different kinds of in different patterns to receive the specific signals or wave pattern as a signal. Interference also important role, because in what way, in whichever mode we are communicating, if there is interference of like the interference of other kind nearby frequencies or any kind of environmental disturbance, that can create interference between the communication. And this is the range versus power versus data rate, that right, we have to manage everything accurately, right? We cannot maximize all these three simultaneously, right? We can't increase that, we have increased power and data rate and range, we can't do that. If one parameter we are going to increase, then other has to reduce, right? Let's say a Bluetooth module, if we increase its range, then most probably the data rate would be reduced, right? So this is the example, right? Long range, low data rate and medium power. And for BLE, Bluetooth Low Energy, medium range, low data rate and very low power. So according to the use cases, that pattern has divided into different communication protocols. Yeah, so that was about the RF history and about the basic fundamental of radio frequency. Now we are going to discuss about the Bluetooth, right, which is very common and we are using from a long time. So Bluetooth was invented by Ericsson in 1994 as a wireless alternative of RS-232 serial cable, right? So it was named after Harald Bluetooth, a 10th century Danish king who united the Danish tribes. Okay, so उन्हीं के नाम पे ये Bluetooth का नाम रखा गया है, right? And ये कुछ versions थे Bluetooth के, right? The good thing about Bluetooth that it get continuously research and development, and continuously scientists are refining the Bluetooth, launching different version of it. So between like something around 1999, the first Bluetooth 1.0 was introduced, right? And then 2004, 2009 and 2010, and in 2016 Bluetooth 5.0 released. And after that still we are using the range of Bluetooth 5, right? But some extended range Bluetooth 5.4. It was the last upgraded Bluetooth range. It was introduced in 2023. And yeah, this is the architecture of Bluetooth, that this is our application. And this is the profile SPSV, HID, GATT. That means how we will use the data, right? It is the depends on use case. Then packet management, that means the data that is coming, how we can break into a proper message, or how we can prepare a message to send over the signals, right? So this is the kind of that data is coming, packet management into the binary. Then HSI, that means host control interface, where we are dealing with our hardware base, that means that communication management over the radio frequency. And last one was the link layer and physical layer, where we are transmitting radio waves, right? This is architecture of Bluetooth, right? And each layer has specific job. Physical layer like manage the radio waves frequency modulation. Link layer connection establish and frequency hopping. HSI manage interface between software stack and hardware. Then multiplexing segmentation of data packets handled by the L2 CAP. Then profile define that how a specific application use the Bluetooth. This is important for our case, that profile, because in Bluetooth we use different kinds of profile for different use cases. And this is about the Bluetooth profile, that the Bluetooth profile define how Bluetooth is used for a specific application, right? Different devices use different profile for different purposes. Before connecting to Bluetooth device, they must be support common profile. This is the important parameter, that before connecting to two Bluetooth device, they must follow same profile, right? It is similar like our hardware communication protocol like UART और I2C, जहाँ पे जो हमारा कनेक्शन है या फिर जो उनका डेटा स्ट्रक्चर है, डेटा फॉर्मेट, वो सेम होना चाहिए. So mostly in the similar case, is a Bluetooth profile. The profile should be matched with each other. Okay. So profile is like SPP, serial port profile, replacing serial label. That is a very common profile in which we are receiving the serial data, whatever is coming as serial on a serial device, right? Second is advanced audio distribution. It is used for in Bluetooth speakers to transmit the music from mobile phone to Bluetooth headset. And HFE is a hands-free profile, right? It is used in Bluetooth headset, earbuds, and phone calls, right? Then HID Bluetooth used for human interface device like mouse, keyboard, and game controller. Then GATT generic attribute profile. It is used in BLE data exchange, used in BLE profile, right? And then GAP generic access profile, right? It is used for device discovery, connection experiment, like whenever we want to connect any kind of nearby Bluetooth devices, then we have to scan it. So for that, general access profile used, right? Then PAN, personal area network, Bluetooth threading and sharing internet via Bluetooth, right? It is rare combination, but it is the most available feature in mobile phones, right? Then message access profile, accessing phone message from car and entertainment, right? We use most from vehicles. Yeah. So this was about different kinds of profiles about Bluetooth. Any doubt till now?
No comment, no.
Okay. Now next one is a difference between Bluetooth and BLE. क्या हो रही थी? Job, it's job. पढ़ लो भाई, तुम्हें काम आएगा. So क्या डिफरेंस होता है ब्लूटूथ के अंदर एंड BLE के अंदर? So like both is called Bluetooth, but classic Bluetooth and BLE are fundamentally different technology. They are incomplete without with each other, right? A BLE's only device cannot connect to a classic Bluetooth only device, right? So in our case, ESP32 support both classic Bluetooth and BLE also. The basic common difference between the Bluetooth and BLE, like it is Bluetooth introduced in 1999, right? And BLE introduced something around 2010, which was that was the version of Bluetooth was 4.0. Yeah. And power consumption, Bluetooth considered as a high power consumption, and BLE is specially designed for the low power consumption, right? And battery life, we can our Bluetooth can drain our battery in hours, but our BLE can run months for the battery. Data rate, our classic Bluetooth has a higher data rate, 3 Mbps, and BLE has a lower data rate, between around 125 kbps to 2 Mbps. लेटेंसी राइट ब्लूटूथ के अंदर ज़्यादा होती है राइट एंड BLE के अंदर लेटेंसी कम होती है, दैट्स वाई इट इज़ फास्ट, इट विल गिव अ फास्ट रिस्पॉन्स. रेंज ब्लूटूथ का कम होता है 10 to 100 मीटर्स एंड BLE का थोड़ा ज़्यादा होता है 10 to 400 meters right, especially in Bluetooth 5.0. And connection time, Bluetooth take at least few seconds, but BLE can connect in milliseconds. And yeah, Bluetooth has 79 different channels. 79, and BLE has 40 channels. Classic Bluetooth used for audio amplifier, file transfer, right, and music play system, right. This kind of things run over the Bluetooth, right, and BLE is dedicatedly for sensors, IoT wearables, right, and beacons, right. Then profiles, Bluetooth has this profile SPP, A2DP, HPP, and HID, right. BLE has some limited profile like GATT, GAP, and yeah. Then typical devices that we use for Bluetooth case, headphone, speakers, right. And for BLE case, we use fitness tracker, smart sensors like this. And this is the reason why BLE consumes so much less power, right. In classic Bluetooth, like pattern is like connected, and it will take a little bit time to connect and fetch the device, right. And it is always connected and always and continuously, kind of we can assume it as a while loop, right, or it is a while loop. So that's why it consumes high profile. And in BLE, right, like it send the data in packets, right. Let's say one packet 2 milliseconds, second 2 milliseconds, another 2 milliseconds, right. So it is not wait for all the time, right, to get the data or to save the data. It just send and sleep, right. That's why it save the power while it is sleeping. So that's why it is only remain active for a very less time when it is required.
Can't we just make the classic Bluetooth to sleep and use it as BLE?
Look, if you make the classic Bluetooth sleep, right, and then to reconnect it, it will may take little bit time again, right. And that's why we can't make classic Bluetooth directly into the sleep mode, or most probably do not have that kind of features for that. And this is about the security of Bluetooth pairing, right. General purpose, what we can do, we can give one option that we can give one pin code, that this pin code we can use for Bluetooth, like one any kind of security password, right. And we can also make it automatic without any locking system that can automatically pair, right. Mostly this kind of case we need in our tracker or kind of IoT devices where we do not want to pair it again and again. But in Bluetooth case, we have to pair every time the device gets disconnected. Either we have to put in automate that every time it get connect. But in BLE, we can configure this that it don't need to connect again and again. And this is the other security patterns, like we can display other similar numbers over the, like Google use for that, displaying similar numbers or two devices to verify that it is secured or not. We can use passkey, right, or we can use NFC or QR code for that, right. These are the security level that we can use in short-term range communication protocol for IoT devices. And Bluetooth security, this is the level of security, is level 1, 2, 3, and 4, right. And according to the need, we can use it. It is included like encryption and authentication and different layers of security. So if you want to enable that for any kind of advanced implementation, we can go for that. Yeah, so this was the theory about the security, and this is the topology of Bluetooth. अच्छा भाई क्या हो रहा है? Yeah, so this is the topology of Bluetooth, right. We call it P-connective topology, right. It's the basic Bluetooth network. It consists of master device up to 7 active slaves. That means there is one master device of Bluetooth which can be connected with the 7 other devices in slave condition. The master control all communication and timing. All slave must be communicated to the master. They cannot talk directly to each other. I think you have seen this thing into Bluetooth when we. I think in Bluetooth era, then when we want to transmit any kind of files in the mobiles, right? So let's say we can connect seven other different mobiles into one mobile, right? And we can transmit from one mobile to seven different, but we can't transmit those seven to each other, right? So this is the topology, right, where we can, but it has a limitation also. The second network is a BLE mesh network. So BLE5 Pro introduced mesh network instead of star topology, one master, many slave. Mesh always device to rely message or to each other, right? This allow BLE network to cover large area, entire building or factory where direct range would not be possible. That means we have this facility in BLE that one node can also communicate to another node, right? It is not only master and a slave communication, but there is a possibility of slave to slave communication also, right? And a message from node 1 and can reach node 8 by hopping through intermediate nodes, right? And used in smart street light building automation. This is the use case for BLE. And RF Bluetooth in industrial IoT. So along with the this Bluetooth, right, there are different kinds of other option for RF, right? Like LoRa, Zigbee, Wi-Fi, and other things, right? And this is the use case for especially BLE, right? BLE beacons track asset location in real time, as in a warehouse management, that we can attach any kind of tracker over the assets, right? And we can track through the BLE, right? And we can also track the location of that asset, because BLE has this feature to you can using the RSSI. Then it is using predictive maintenance, like to monitoring the machine or other things through the BLE. Worker safety like giving a security band for them to alert on specific events. Cold chain monitoring, right? That means maintaining the temperature of different kinds of objects or material. Then smart meter reading, right? Taking the meter from electricity meter directly to the BLE. And effective floor BLE gateway collect data from hundreds of wireless sensors. And yeah, so these are the few basic key points that you can remember, or you can read this question or get answer from LLM, right? If you want to practice for interviews. Yeah, this was about BLE in Bluetooth theoretical part. Now we'll go for practical implementation. I think Jatin is here or not? No, Jatin is not here. Praveen is not here. Sorry, Praveen, you are here. Sumit is not here. Roshni. 3 persons are missing right now. Okay, so what I'm planning that, because Bluetooth is a very short topic for everyone. If it get missed, that means it will get missed, right? It will not come back later. So what we can do? Can we have this was suitable? Can we have practical later on Bluetooth and BLE? So tomorrow, so that